next presentation by Professor Marinos that is a pre-recorded one, since as Professor Marinos will explain he's participating in a summer school. So let me try to share my screen and start this presentation.
Good evening. My name is Vasilis Marinos, and I'm an assistant professor of engineering geology and rock mechanics in the School of Civil Engineering in NTUA in the geotechnical division. First of all, let me apologize for not being able to attend live in the webinar, but I have a summer school running in the same hours. So this video is recorded. Let me share my screen and start this presentation. So the topic of my presentation is geology and seismic faults. However, I have to say that from our side, our main focus during this mission was to identify geotechnical failures and try to relate them with the geological environment. However, for the purpose of this webinar, there are a lot of topics also discussed with the geotectonic setting of the wider area, the tectonics of the area, and then we will gonna finish this topic with the geological conditions in the sites we visited, the ground ruptures, and we will try to correlate these ground failures to the site-specific geological conditions that we identified in the field. Before continuing, I have to acknowledge all these sources, and mainly all this material has to do with the tectonics of the area. These three first sources are gratefully acknowledged, and all the other websites of the mass media of Turkey and relevant institutes also. So first of all, let's see the geotectonic setting of the wider area. The Pasarcık earthquake that occurred in around 4:17 morning Turkish hour, and the Kinoju earthquake after 9 hours in the same day. And the earthquake, as we know, involved rupturing on the segments of the East Anatolia Fault and the Dead Sea Fault. Here is another view of the events along the two faults in relation to the wider geotectonic framework, and we're gonna see these faults in detail, and we'll try to see how these were triggered. The Pasarcık earthquake is a northeast-southwest trending fault with sinistral slip, involved two segments of the East Anatolian Fault and the Dead Sea Fault, one segment of it. The total length of the surface rupture could be moment magnitude of this earthquake has been estimated by the different institutes, ranges between 7.7 and 8, while the Kinoju earthquake is an almost east-west trending fault with sinistral slip, and this fault might be a combined slip of Kardak and Surgu fault that has a moment magnitude between 7.5 and 7.7. Here we can see some figures related to the prior and post seismicity. This is the prior seismicity of the 7.8 fault. And here we can see the post-seismicity of the 7.8 and prior 7.6 on the left side, and the post-seismicity of the 7.6. We will see more in detail in the next slide, so I'm moving on. Here we see the general, let's say, geotectonic setting of the wider area of this corner of the Earth. You can see these two big faults in relation to the tectonic plates, and we know that Turkey is located in this Anatolian block, lies in a triple junction between the Eurasian, African, and Arabian plates, and the Anatolian block here is bounded on the north side by the North Anatolian Fault, and on the southern eastern side from the East Anatolian Fault. We can see also the Hellenic and the Cyprus subduction zones in the south, and an extension regime in the west, together with all these accommodates a relative counterclockwise rotation and westward motion. Here we can say now that the events on the February 6th were initiated by a smaller gnarly fault splay of the East Anatolian Fault. We will see that more in detail, which then propagate this East Anatolian Fault in a bilateral manner from the center out, then to the northeast and to the southwest, resulting in this 7.8. And then 9 hours later, another event occurred in the Surgu-Kardak Fault, resulting in this 7.6 earthquake. You can see in this slide, in the red line, these main faults in the plate boundaries, and in the lighter gray lines, all the other faults. Here is another nice figure, shows the post-orogenetic extension during the Oligocene and Miocene in metamorphic rocks from GPS measurements, showing all these movements of this Anatolian block. And here you can see again the epicenters of the two faults related with these fault segments we already discussed. Here is a very recent paper from Elgar et al. That shows that we can see these big faults, these two big faults related with a 7.8 to 7.6 earthquake, but here it is believed that the first events nucleated on a previously unmapped fault, this nudity basaltic fault, before transitioning to the East Anatolian Fault, like we already discussed in the previous slides, rupturing for about 350 to 400 kilometers, and the second one ruptured the Surgu Fault for about 150 to 170 kilometers. Here is a perspective view of these two big earthquakes and the ruptures of the East Anatolian Fault and the Nugdehi Basaltic Fault and the Surgu Fault. We can see here the best fitting slip distributions. In green, you can see the population centers in the region. And in the upper right small figures, you can see the source time function for both ruptures, while in the lower right side, we can see the root mean squares misfit as a function of the maximum rupture speed. You can see that the best fitting values are 3.2 kilometers for the 7.8 event, while we can see for the 7.6 event, 2.8 kilometers per second rupture speed towards the east, and the 4.8 kilometers per second towards the west. As we said, it is estimated now that the total length of the rupture is for the basaltic earthquake is up to 400 meters, and the Kinozu earthquake around 160 kilometers. And here from relations regarding the Turkish earthquakes, but also worldwide data, as we all know, relating the fault rupture length with the magnitude, almost fit well here. As far as the slip is concerned, for the 7.8, but also for the 7.6 earthquake, we see a slip of about 5 to 8 meters. And now let's proceed to the geological conditions. We can see here that mainly the geomorphology of the Eastern Antonio Fault is dictated by a river valley following this fault. So this is the main, let's say, morphology that dictates also the failures in all these cities. However, in most of them, the surroundings are composed of limestone rock masses. For the purpose of our missions, we collected where we visited all these population centers that were most affected by the earthquakes. We have collected a lot of geological and tectonic maps, and we have just partially referenced in preparation for these missions. And all these maps were incorporated into Google Earth for enhanced visualization and analysis. We also identified a lot of surface ruptures in Gülbaşı, Osmani, and of course in Antakya airport area. Also in Turkoglu, where we can see here a very clear slip in the road, but also in a very small gouge here. Here are let's say we have all see these very nice pictures, mainly from the GR reconnaissance. They have made a fantastic work here, and we can see in some areas in Turkoglu, Antioquia, these ruptures. These are typical surface ruptures with less common rupture locations, included breaks along the tops of ridges and bedrock slopes. So most of them are situated on the river deposits. Again, here we can see the slip for both events were as large as 8 meters, as we said. There is also a vertical component in some, and this also can be connected with these very high inflows of water we had also in the Skenjerum. And there is also a vertical component in other places. So we see here that the geomorphology of this East Anatolian fault, again, is dictated by river valley, and the river deposits in saturated conditions are of course present. Now let's go to the areas we visited. Here in Gülbaşı, you will see that we have a basin that is formed by two faults, two parallel faults, as we see in the left side, and there is a clear zonation of extensive damage to buildings along and around these recent lake and river deposits composed of very soft sediments. Then in Maraş, again, we see that these damages are extensive in very recent loose and soft sediments, and they are reduced in the hilly areas, which we have more consolidated sediments. Again, maybe not a bedrock still, but there are neogen mostly age, more consolidated alluvium bedrock. And then we can see in Turkoglu that we have the fault that extends exactly on this area, and a lot of extensive damage were identified in this area, in the road network, but also in this industrial zone. In Antakya, we had severe damages, as you will see in the next presentations, and the city, it is extended in very recent quaternary deposits, and there is a direct proximity to the fault. Unfortunately, we did not have the chance to go in the wider skirts of the city to see how these failures are fading through the hilly slopes where we have more consolidated sediments, but also the bedrock. We saw that in other cities, and definitely, as we saw from far away, there is definitely reduced catastrophes in these areas. In Adiyaman, again, the city is built on recent soil alluvial formations in talus, and part of the fault extends of the outskirts of the city. So you can see also from the map these very, very recent sediments, and some photos we had the chance to identify on the ground on the surface. And again, in the Skenderum, it was fascinating to see still all these areas flooded parallel to the sea zone. We had significant settlements there, but also liquefaction phenomena. All this area composed of loose sandy deposits, and of course the vertical component of this fault from this side led to this extensive flooding. On the Islay, though there is a proximity to the fault, so these damages are more limited in the extent of the city, because a big part of it is founded on rock, mainly basalts here. That's why we identified less damages, not that were not present, of course, in the lower parts of the city where we have more recent sediments, but we mainly visited the hilly parts here. Then going to the rockfall incidents in the Islay region, we identified a lot of rock blocks and limestone within this more mountainous region. Of course, big landslides have been identified in many areas along these catastrophic earthquakes, but mainly in Tepehan, and you have seen all these photos. We didn't go there though. We mainly visited, and we were very lucky to see this mountain scale landslide. This, as we call it many times, also landslide dams that blocked the river here. And we found that the last minute, literally, the road was blocked, but we did some more kilometers very carefully, and we reached towards this mountain scale landslide, which is composed of million cubic meters. It is a limestone which is heavily fragmented and karstified with extensive clay zones, and it is estimated of decades of a million cubic meters. Here I would like to thank you very much for your attention, and I hope to have a very nice webinar. Thank you very much.